Hello, my name is Manasi Sarkar. We are excited to participate Microsoft Fabric Hack Together Challenge. My team name is Kappa Pinia. We have submitted 3 business use cases in GitHub. The first use case is about the legal document summarizer. The legal document summarizer will help the end user to give them their answer based on their uploaded document or any contract document. Because in the real life scenario, the contract documents are very much complex, so it will help the end user to give their corresponding answer for their questions. The second use case is all about the real-time streaming data ingestion in Microsoft Fabric. We have ingested the US Stock Exchange data. This US Stock Exchange data is basically the whether the data is bearish or bullish, so that analysis or business decisions can be taken from Power BI report. So we have one Power BI report that is basically showing all the real-time data of US Stock Exchange. The third use case is about the image classification. We have used the Azure AI services, the image classification component for this use case, and this use case will help the whether for a automobile or any kind of road detection or any signal detection for any real life scenario. Thank you, everyone.
So, hello everyone. So today we have come here to discuss about one of the use cases for the Fabric Hackathon 2024. So in this use case, we are discussing the implementation of a RAG application. To build the RAG application, we are using the use case of a legal summarizing document. So as we know that in this in a legal document, today's legal landscape, professionals are inundated with vast amounts of documentation ranging from contracts and statutes to case law and regulatory texts, and extracting relevant information from these documents can be time consuming and labor intensive. So we have tried to implement an RAG application that primarily aims to summarize legal documents in an interactive question answering based system, and also derive meaningful and key insights efficiently and in a quick manner. So in order to use this application, we first will be using the Fabric environment. So we will be using Microsoft Fabric. So in Microsoft Fabric, we can use any of the data engineering or data science experiences. So for simplicity, we'll be using the data engineering experience. So in this data engineering experience, in order to solve the use case, first we need a notebook. So the entire thing that works in a Fabric is in the form of a Jupyter notebook. So once we are there in our workspace, we can create our own workspace as well. So as you can see that I have created a workspace over here by the name of Hackathon. So first we need to create a notebook. So once we are done creating a notebook, we can see that this is the name of the notebook. You can create your own name according to it. So before doing the coding in the notebook, we have to first import a lakehouse. What is the lakehouse? Lakehouse will basically store the documents that will be used in order that the custom documents that will be used by the RAG application to summarize and extract documents. Basically, that will be the legal documents that will be stored in the lakehouse. So I'll show an example on how we can create a lake house. We can make a new lake house by this option, or we can choose an existing lake house as well. So I'll be just creating a new lake house. You can just give RAG data as the name. And if we can create this lake house, you can see that this lake house is being created. It might take a couple of minutes to create the lake house. And yeah, it is created. So once it is created, you can upload files from your local system, and or you can also use some kind of API calls from various sources in the online system. We can pull data from GitHub or any other online resources as well. So once you have uploaded your data over here, suppose I'm uploading a demo file over here. Suppose I am giving this as a document and I'm uploading it. So it will take some time and it is uploaded. And after that, if I just refresh over here, I can see that my document has already arrived. So that's one way to connect your lake house with your notebook. And in this Fabric notebook, we can code just like in a Jupyter notebook. So for simplicity, I'll be using the VS Code option over here. You can also transform all this environment in a VS Code setup. So if I go and open VS Code, it will show that it will open in my local VS Code system. The entire notebook will be shifted into a VS Code IDE. And there you can see that the notebook a.ipynb notebook is created over here. You can code over here and run the entire code as expected. So as we go ahead with our coding, so we will just what we do is we have already created a documentation of the entire problem statement. I'll be just walking through the entire code. I have already created another application of the same thing. So in order to save time and to just facilitate it easily, I'll just copy and paste the code from this documentation, and I have masked the API keys so that it's not visible. But while coding, I'll be using the keys. And then I'll be going through, I'll be giving a walkthrough of this documentation to show that the reproducibility of the code is feasible. So in order to make this application, we have used LangChain as a framework for text processing, text splitting, and vector storage. We are using the OpenAI embeddings that offer powerful representations of text that capture semantic meaning by utilizing OpenAI embeddings. And the FAISS is the library that we have used for clustering the dense vector and for vector search. So that is the key things, 3 things that we'll be using. And in order to do this, you need to have your own OpenAI API key. So the API key that will be shown here will be disabled after this demonstration. So that key won't be visible and that key won't be reusable after a certain while. So once that is clear, so let's go ahead and get started with the code. So I will just open up the folder where I have actually done the code previously. So just let me set it up and we'll start from here. Documents. So as you can see, So in order to, as a document, I'll be using the Kaggle terms and conditions as my primary legal document. So if I just go here and paste it in my location. So, okay. So these are the document and these are the codes that you can see. So everything will be uploaded in this GitHub repository in this RAG folder, including the documentation, the code that needs to be run, and everything. So basically, if I go ahead and click on this code and let me just, it will take some moment. Yeah. So this code is already done. So I'll just copy the code from here and will be pasting this entire thing over here. So just to make sure that you need to have certain libraries pre-installed, which I'll be showing over here in the requirement.txt file. If you go back here, you can see that there's a requirement.txt. So these are the primary libraries that you need to have pre-installed in your system. In order to do it in the notebook, you can use this kind of system like pip install, say OpenAI, or like all these libraries can be installed here as well. So if you just click it here and do it, so in that case, you can just do it like this. So if you just press enter, the session will be commencing and it will take a minute to start up the session. So as you can see here that the session is starting in ML Fabric. So yeah, it is showing us the output that the requirement is already satisfied because I have already installed it previously. So coming back, so here in my local, in this VS Code system, it is already installed, and you can also use a requirement .txt file, and in that txt file you can actually paste your requirement.txt documents, and after you have done it, you can just open a terminal and use and write pip install -r requirement.txt, and since it is already installed in my system, it will show that the data is already, the libraries are already installed, and we can go ahead with coding. So once we start running, we need to first make sure that we have our environment set up, that is for a Python environment setup in Fabric. The current version of Fabric gives a 3.10 setup, so 3.10 version of Python. So as you can see that once I have adjusted my the correct version of Python, so the entire code will start running. So after that, we'll just go ahead with this file that contains the entire notebook. So you can read the entire documentation. So as I have shown here that this is not the correct way to give your keys. You can use an environment variable as well. So this thing will be masked after this documentation. This key will be removed. So that key will be removed after this documentation. So now what we are doing here is, for the first step that we did here was importing the necessary libraries that are required for this project. And in the next case, I am just importing that's like setting up my environment key with the OpenAI API key that I have. After that, what I do is I will read the PDF document that I have. So in order to do that, I'll just go ahead in my notebook, and if I can show that we can also use a copilot over here. Read Kaggle terms and condition as a PDF file. If I give it over here, and let's see if, as you can see, that it is showing that how the PDF is getting read over here. This is the Kaggle terms and conditions. So you can keep it if you need it, but the code that is generated in a Copilot is in a much more detailed fashion. So I'll just write it in a more Pythonic way. So I can accept it or I can discard it. So this thing will work. I just have to replace this path with the actual path in this document. So if I just replace it with this, so if I just replace it we'll be discarding it for now, just for our code completion. So let me check over here. Okay, so I think, yeah. So if I just do it, as you can see that the terms and conditions has been, the terms and condition document has been read. Now, if I go ahead and read the raw text from this document, we should be seeing the raw text that has been generated from extracted from this document. So up till now, what happened is I have installed the necessary libraries. Then I have initiated my initiated or set up my API key. Then I have read the document which needs to be summarized and the information needs to be extracted from using the PDF reader module. And after reading the entire PDF from its location, I have extracted out the text, the raw text from the data. And as you can see here, the raw text is separated by a new line. This is an escape character. So basically it is just throwing out the raw text. Now we'll move on to the next step. For example, also there's a nice explanation on how we can, I'm saying this in my own terms, but also I can use Copilot to basically tell me like what this code actually stands for. So explain this code. If I show them, and if I give it to it, so it will exactly give us like where this was referenced, and also it will give us like what it is trying to do. As you can see that this Python code is used to extract text from a PDF. Basically what I just said, this line imports this is the importing the module, and this is the like line by line it will show us what that particular line is trying to do. So in this way, Copilot is a very useful tool. One, you can do a pair programming. Also, you can read. It also improves the readability of the code by giving us an idea on what others code has. If you're supposed to read what I'm trying to do, and if it is not well documented or well commented, you can just simply ask Copilot and it will give the result as intended. So, okay, yeah. So that is done. So this step is already done. So why am I writing it again? So anyways, moving on. Now what we will do is we will be splitting the text and tokenizing it. So what we are doing is we are using the character text splitter method. It basically chunks the text into tokens, and using the character text split, we are using it so that it does not increase the token size. So if we run it, and if we see the len of texts, if we see its Copilot is already suggesting the method completion. So it is a very helpful pair programming assistant as well. As you can see that out of this entire text of say 20, this was a 20 pages PDF file. So it has generated a 52 tokens out of it. So now what we can do is, once this tokenization is done, we will import the download the embeddings using OpenAI embeddings. So once we are downloading, it will show some warning that we can ignore that warnings, and we can see that the embeddings are done. If you want to know more detailed on what it is doing, you can always ask Copilot and tell them explain this. So it will again give us the reference of the code snippet, and that is where it is referenced, and it will give us an idea on what it is basically doing. So the OpenAI embedding class is not defined, but it is assumed to be a class that can be the embeddings are in the form of word representation that captures aspects of its meanings and are used in NLP. They are typically pre-trained on a large corpus of text, and they can be used to encode words in a way that preserves their semantic relationships with other words. So basically, this is what what Copilot did was explain the entire OpenAI embedding method. So moving on. So now what we will do is, we have our text ready, we have our raw text ready, we have our OpenAI embeddings. Now what we will do is, we will use vector search to search our text within that embeddings and generate out meaning out of it. So basically we are doing a context search in this. And if it is, yes, you can see that once it is done, we have stored the entire database in a vector storage, and that uses the LangChain OpenAI. And after that, we have used the files to do the vector search on the text based on my embeddings. So these are the two parameters that has been sent. And as you can see that it has generated a vector stored object. This is basically a vector object that has generated that the search is successful. And now we can go ahead creating our language chain so that we can query and get the desired results as per our requirements. So in any case, if you have any doubt in what the particular method is doing, you can always go ahead and ask Copilot to just explain that particular snippet of code. So then, as you can see that the chain is also generated, we are using OpenAI for this. So now, coming to the most interesting part, where we will be querying the data, we'll be querying the document, and it will go on in a never-ending way, and as long as the user says they are satisfied with their answers and they are now happy to quit it. So suppose I'll be just asking like, what is the title of the document? And before I write, this says that the enter your query or write end to terminate. So as long as I don't write end, this particular word, it will keep on giving us the responses as long as the user is not satisfied. So if I can see, okay, so maybe my API key. So if as now we have come to the final part of this application, where we will just query the entire data, the main interesting part. So if we just go ahead and run the entire code, we can see that while this one running, the query says enter your query or write end to terminate. So as long as the user will not write end, it will be generating the question and answering system. So if I just say, what is the title of the document? and it will say that the title of the document is terms of use, which is true. If you can see that the terms and conditions, if you open the document, you can see that the terms of use is the title of this document. So this proves that the notebook that we have built is basically working. So if I say that please summarize the document, it might take some time in order to run, but it will summarize. See, the question is please summarize the document, and the answer is this document outlines the terms and conditions for using the services provided by Kaggle, a company based in Mountain View, California. Users must agree to these terms and conditions, and the entire summary of the entire 20 pages is done in a couple of lines. So this basically validates that our code is reproducible and it will work in case of this question answering query. And if I have certain, if I open the query and say, suppose if I pick up a random term, Kaggle takes privacy is very serious. For Kaggle, private click here. What are the basic uses of Kaggle? So if I just copy this question and give this question to the prompt, let's see what it gives as an output. It says to use Kaggle, you must agree to the terms and conditions and follow the rules and regulations set by Kaggle. You may need to pay monetary fee. So entire thing, we can simply question and answer it. And the model will basically, what it will do is, it will extract information from that document and give us the output. And even if the document is, if the information, that question that is asked by the user to the document is not present, it will just give that it doesn't know. Say for example, if I just give a random question, it will just say, what is the name of the document? If I say what is the name, if I just say this, it might give the name is Kaggle, because it is in the document there is some text that says that the name is Kaggle is entitled over in the text. So if I just press end now, it will say it's terminated and the code gets stopped. So this way we can generate an interactive chat environment by the with the document that is basically being read by the model, and then we can take out meaningful information and derive insights from it without having to read the entire large documents. So this is a key example on how basically we are using the document in order to, we are using this RAG application to summarize legal documents, and we are also using we are using it as a method to extract information and generate key insights of it. So with that, I would like to conclude.
Welcome everyone. Today we are going to use real-time streaming data for analysis. In today's world, we need to act accordingly in many situations where data is a real-time one, like stocks data, weather report, market data, flight availability, train seat availability. On these many equations, we need something where we can just check out the live status of these data. So today, we are going to show real-time streaming data analysis on US stocks. It's important for stocks and market analysis to have a report on live data where the user can choose the view they need on a particular stock, or maybe the trade they need to visualize before doing the trade. So for that, the user might need a real-time report so that he can act accordingly. So we are using Microsoft Fabric and Copilot for this course of action. So I will show the use of Microsoft Copilot that we did in this code. Excuse me. So here you can see that we asked Copilot for the help of changing the column types. So this thing we just copied from here and pasted in this part. Then we also needed the system time when the code will get the data. On that time, we need the timestamp for that. We used this code snippet provided by Copilot for that purpose. And also, we asked how to save this data frame from Panda to a CSV file. All these implementations are done in Microsoft Fabric. So, let's go to Microsoft Fabric. So, we actually did all this part in Microsoft Fabric Synapse Data Engineering. We created a notebook for our course of action. We are fetching data from this central chart. So from here we are taking two different tables. One is Nasdaq, another one is NYSE stocks. So for that we are web scraping the data from these tables and putting it on our data frame in Pandas. So after that we are just saving the whole data frame into a CSV file in our Lakehouse. After doing that, we are changing the column types according to our need and saving those in Delta format. Why Delta format? Because in Fabric it enables us to use this Delta file directly for our report, because it generates an automatic SQL endpoint and a semantic link from this Delta table, where we can create our multiple views, different SQL queries, different measures, and also model the data we are getting. So first step is done, getting ready with the notebook. After that, we needed a real-time data from this website. This is a free website. There are also many free websites. You can get your data of stocks from there. So we used the data engineering pipeline feature provided in Fabric, where we created this pipeline notebook and we did schedule run on this one. Currently it's off. I'm just showing you how to switch it on. Select a frequency on which this data will be captured through the notebook. If you want it by minute, then minute, and put the minute, like it's on a 1 minute interval or a 2 minute interval, and from which date to which date this pipeline will get triggered. So I'm just putting it today's date and time and end date of Tuesday maybe. Okay. So after this is done, you just need to hit apply and this pipeline will get triggered in every 2 minutes from this time to this time. What it will do? It will run the notebook on every 2 minutes and will fetch data from the API and put it on the data frame. From that data frame, we will generate the Delta file that get appended on our Lakehouse. So closing it over here. We did that part. So I'm heading for the Lakehouse. Yeah. These are the two Delta files we are having, Delta tables. You can see, and from here there is an SQL endpoint. So what it's provide, it can help us with new measures, different views on our table that we want to see, like selecting top 10, selecting top 30 from any stock. We can also model our data using this model part and query by SQL query. We did all those, and we also created few measures here and here, and made a report from this new report. Or you can just connect this Lakehouse with your Power BI to get the report from your current data. So why it's important? Yeah, because in this delta table, the data get updated on the frequent run of the pipeline, and just on a refresh, the Power BI report will also get automatically refreshed from this current data. So no need to work additionally. It's Fabric feature that's enabling us. We already did a report on this. Let me just show you. Yeah, there we go. So it's showing the data report from the delta tables. There is the Nasdaq one, then there is the NSE one, and user can have their own customized report on a particular stock on a basis of their timestamp, like how the trend is going on the market, what can be the predicted line from the BI report, and it's get automatically updated as the new data comes in on the delta table. So that's it. Thank you.
Hi, hello everyone. So today we'll be having a demonstration about this image detection model that we are building. So basically, the model is developed in Microsoft Fabric using Azure Cognitive AI Services. So in that model, we will pass an image. Basically, we'll give an image path, and after that, the model will detect the objects based on the whatever parameters that we are giving, and after that, we'll get a description about that image. So let's start with this image first, and we'll see how accurate
Things
the
go
model
on.
is. Sorry.
So we will start with this image and we will just show that how things go on
Yes.
this image. Okay.
Yes,
Yeah,
like
okay.
whatever we are expecting, that the model will give a description about this people having meet or having conversation, and there are these people are there, coffee cups, laptops are there. So let's see what this model will do. So this is the model that we have developed, and as you can see here, we have used Azure AI Services. Okay, and this AI service requires some parameters on which the machine learning model will run. So in this, so we have given category, description, and objects parameter. Okay, let's run this code.
Pardon me, Lokesh. So we are running this whole thing on Microsoft Fabric, right?
Yeah, we are running this in Microsoft Fabric using PySpark Python language, and we are using Notebook, which is in Microsoft Fabric. And additionally, we are using Azure AI Services, this cognitive service, which is available in Azure.
Okay. And about the image part, so from where we are getting that image?
You can get that image anywhere. You can also click an image and just pass it to this model. You can give the image path to this model and it will detect the objects.
Oh, okay. So in our case, we are using Lakehouse for that purpose, right?
Yeah, we are using lakehouse. Basically, the fabric in fabric, there is a
Yeah.
lakehouse concept, one lakehouse. So
Yeah.
in that one lakehouse, you are dumping any file, any type of files, say from anywhere. You can dump your data in that lakehouse, and then you can do data engineering, reporting, data analysis, whatever you want, like anything. So here the model has given the output. Okay, let's go to the top. Okay, another thing that I missed out, that in the what additional features we have added to this model is that we have given an image, right?
Yeah.
So as I previously said, it will give a it will detect all the objects. Here you
Okay.
can see all these red box. These are the images. These are the objects that is detected by the model. Okay. Now what we have added is that the model will crop this detected image, and it will further iterate on those cropped images to detect any other objects that is present in those cropped images. So here you can see this is the first iteration, completion of the first iteration. After that, in the second iteration, it will go in those cropped images one by one, and it will detect any object that is present. As you can see here, this coffee mug that is present in this image, which was not detected in the first iteration. See, there is no coffee cups that is detected.
Okay.
So this is the so this is it, and the response that
So,
we will get from Azure AI service. Yes.
so basically we are detecting object from the image and then also like recursively identifying the individual object and going further on that. Something like this, right?
Yes, exactly. That is what we are doing. And as I said, okay, the Azure cognitive service, it will give the response in JSON format. So this is the response that we are getting. Okay, and the question is that like, what is the end case, like when it will stop the iteration? So if I go to the last part, okay. Here you can see this is the end of those iterations. So whenever the model will detect will get no other object, like this object array is empty or null, then the iteration will end. That is the end case that is present in this model that is added. Okay, and as I have said earlier, that it will also give a description, like, about that image. So here you can see there is a text, a group of people discussing something that is like 100% right. Okay, so after that you can see a blue square on a white surface, a man sitting at a desk. Okay, here you can see a man explaining something to a woman, and that is that you can see from that image. Okay, and here you can see there is a text, a man in a suit and tie. So these are the details that the model can extract from an image that you are giving. So there can be multiple business cases, say for automation driving, like this is what we are focusing on. So you can get any road image, and you can detect what car, traffic lights, anything, and then you can build a model, automation driving model, where it will detect object, and you can pass an object in the clear, say where there is no object, it can move in that direction.
Yeah,
So
so
that will be,
basically it will also describe the identifying features from the
yeah,
road image
definitely.
or a traffic path.
Definitely. So let's I think it will be better if we have an image like that, and let's see what the
Okay,
model can do with the traffic image. So
okay,
here
that's
this
interesting.
image, let's see. Okay, Here's the model on the image.jpg. So that is a traffic image, the highway image. Here you can see the first description it has given. Okay, it's detecting. Let the model run.
So
Mhm.
from my
So here
curiosity
you can
part,
see.
excuse me, Lokesh. For my curiosity part, I just want to know that this cropping image that we are getting from a first image. So how the model running iteratively on those images? Like, are we storing it over somewhere or something like this?
Yeah, definitely. Like where you are passing an image, and whenever, like as I've said, it will crop those objects, right? In that
Yep.
in that image, whatever objects it will detect, it will crop. So we are saving those images in the lakehouse in a
Oh.
path. So we are specifying a path, a file path, and we are saving those cropped images in the lakehouse. Here you can see this image folder that is present.
Yeah.
Okay, let me refresh it. The first I will explain this. So you have seen these car images, right?
Yeah.
It's detecting these car images, and there is a description about that car image. Sorry, outdoor road, etc. I will show those cropped images where it's saving. Just wait. Let me refresh it after this. You can see these images. This is a folder or the image folder, and the file path that is given where these cropped images are saved. You can see here cropped image.save lakehouse default files image detection.
Yeah.
So all those cropped images that has been detected by the model, that will get saved in these folders, like any folder you want. Like it's not
Okay.
specific.
Okay. So have we got the data on the traffic one?
Still running. Let me see.
Okay, it's still running.
Yeah, here's the response that we get. Okay. Let the model run. Yeah. So you can see all those cars which are present in the road is detected by this model, right? And the description that we have received is that it is a land vehicle. So as you can observe, like here we are specifying the categories. So what this category parameter will do, like the model will segregate the objects based on the categories also. So since there are many vehicles that are present in this image, so it has segregated those objects as vehicles, right? So you can see vehicle, then outdoor road, etc. So similarly, we can have the category on traffic lights, and we can say specify in the model that whenever you are detecting traffic light category, then if that traffic light contains green or say red light, if it is red light, then stop, and if it is a green light, then the road is open to you. You can drive.
Oh, so basically we can manage our customized action based on the detected response.
Based on the detected response, like we can use these features like categories. What we can, you can redefine the parameter, like Here we have just used category description objects. You can add many parameters which are
Yeah.
available in the cognitive service.
Yeah, something like traffic signs or a board
Traffic,
to
no,
stop,
traffic
something
signs,
like
boards, yeah, that will get detected in the categories only.
Okay. Okay. Thank
You
you for the
you can
clarification.
add colors. You can add colors to be specific.
Oh,
You can add colors. There
okay.
is an option to add colors.
Okay.
Okay, thank you.
Thank you,
Like
Lokesh.
if like you have any questions, you can ask. Otherwise, if it
No,
was a
it's
great conversation with you, I hope I have demonstrated you well.
thank you, Lokesh. Thank you for explaining all those bits. Yeah, there we go.
Okay.